Hello everyone, welcome back to my YouTube channel. In this video, we shall discuss on a question related to adiabatic expansion. So let's get started. An isolated gaseous system containing 5 mole of argon undergoes adiabatic expansion from standard temperature pressure STP to a final temperature of 270 Kelvin. Given that the adiabatic index for argon is 1.67, determine the work done by the system in joule. Alright, so this is a rather straightforward question. You just have to use the equation, which is the work W is equivalent to NR divided by the adiabatic index minus 1 times T1 minus T2. Right, so in the question given 5 mole, so here is 5 mole. And your R should be equivalent to 0.0821 liter atmosphere divided by mole Kelvin. Right, all these things divided by 1.67 minus 1. And then your T1 is 273 minus the T2 is 270. Right, so you will end up having your W is equivalent to 1.8381 liter atmosphere. So because this one is Kelvin, right, this one is mole, so this one and here, so you end up having this. So you were asked to calculate in joule, so you need to convert. So 1 liter atmosphere should be equivalent to 101.3 joule. So this one, you just have to times 101.3. So it's going to be 1.8381 times 101.3. So you should get 186.1995 joule. So this is the final answer for this question. Thank you very much for watching this video from the beginning till the end. So I'll see you again in the next video. Goodbye.